Hello everyone. So welcome back to another episode. So as promised is that we are going to talk about now is about the load flow analysis. So we had talked about more of the Gauss-Seidel and the Newton-Raphson, which is part of our general topic na load flow analysis. And we had given the derivation of formulas, we had given general examples as well as two-bus system examples sa Newton-Raphson natin. But now we are going to dig deeper in analyzing both the Gauss-Seidel, the Newton-Raphson, as well as yung line flows and line losses natin in a given circuit, where today we are going to answer a certain problem na matatakel yung four na sinabi natin need nating to have a deeper analysis into. So as of today, we are going to answer exercise 7.1 in page 184 of the book called Electrical Power Systems by D. Das. So D yung initials niya, there is no explanation to that, and his surname would be Das if he's he. Okay, so now our load flow analysis about the electrical power systems. Of course, may roadmap pa rin tayo. So our roadmaps will start off with the first iteration using the Gauss-Seidel method. So just to give a heads up is that we are going to solve only two iterations for today, and we are going to tackle or answer a problem which is more of a three-bus system. So our second is that, of course, the second iteration using the Gauss-Seidel method. First iteration using our NR decoupled method. Second iteration natin ng ating decoupled Newton-Raphson method. Then we are going to solve for the line losses, and we are going to solve for our line flow. So this is a warning. Now, this is going to be a very long video because we have a lot of things to discuss. We have a lot of formulas to undergo, especially two iterations pa siya. Pero clearly, yung mahaba lang naman sa atin would be yung first iteration. Then yung second iteration, small na lang yung mangyayaring computation because we had generally answered sa first part na. That is why we are just going to associate yung nakuha nating V2 and delta 2 doon, or angle natin doon sa first iteration, then do sa second iteration, yung gagamitin natin. So enough with that. Now we are moving forward to the problem in exercise 7.1, page 184. If you have the book, you can look into it. But the problem na lalabas doon is ito rin. So in-screenshot ko na so that we could have a reference kasi gagamitin natin itong table 7.4, both for the load generation data and line impedance. It is very important for us to know it because yun yung magiging foundation natin sa pagsagot ng GS and R, and of course the line flows and losses. So the problem is that load and line data of a three-bus power system is given below. So we have to solve for the GS method up to two iterations. Second is that we have to solve this problem using the decoupled Newton-Raphson method up to two iterations. Then we have to calculate for the line flows and the line losses. So kailangan ang GS and NR natin, yung sagot na makukuha natin sa kanila would be almost the same. Nagkakatalo kasi yun when it comes to sa pag-round off. So it may differ yung answer sa pag-round off. So but in the end, they must be close to one another. Yung discrepancy nila not as much dapat. So yun doon natin mapuprove that we had used both the GS and NR formulas properly. So sa table 7.4 natin, the load and generation data. So we have the bus code, assume bus voltage, generation, and the load. Sa generation natin, we have no value. Sa load natin, as you can see, sa MW, we have 390 and 290 for our bus code 2 and 3. And for our MVAR is that we have 310 and 260. Yung assume bus voltage natin, that's the voltage of V1, V2, and V3. So that's all 1 plus J0. So basically just 1. So yung bus code natin, as you can see, makikita na may slack bus tayo. Always, we have discussed that this sa ating previous videos na yung first bus natin is a slack bus, then 2 and 3. So we are going to end up solving for our V2 and our V3 and delta 2 and delta 3, okay? So we have to keep that in mind. Ito na yung given natin eh. Hindi na natin siya isusulit sa next slide as it is given in the table already. But later on, there will be datas na i-enumerate natin so that we won't get lost in the process. And as for our line impedance over here in 7.4 then, 1 to 2 natin, bus code 1 to 2 would be 0 plus J30. And 1 to 3 would be J0.0125. 2 to 3 is J0.05. I don't know if sadya na onte or not complicated as much yung given na data natin, but this would be a good heads up or starting point for us to solve for a 3-bus power system. So now let us solve for the 2 iterations using Gauss-Seidel method muna, of course. The first thing that we have to do is to get the initial computations and to convert all the loads in the per unit values. So kita natin kanina dun sa table natin is that sabi natin dun sa MW na part sa load is that may 390 tayo, and as for PL, dun sa third natin is 290. So yung 390, so balik lang tayo para makita ninyo because hindi ko siya nalagay. Yan. Itong load na to, ito yung isa-solve natin, kailangan natin convert sa PU. Convert sa PU because yung MW and MVAR natin, we have to divide it by 100 para makuha yung per unit value ng ating load. Kasi yung generation natin, equal na siya sa 0 because wala siyang value talaga. So, ang mangyayari mamaya to get the PU is 390 over 100, 290 over 100, 310, divide 100, 260, divide 100, and so on. So, as you can see here, is that yung initial computations natin, 3.90 PU na siya. For PL3 is that 2.90 PU. Yung QL2 natin is that 310 siya kanina, divide 100, 3.10 PU. So basically then yung ating QL, this is 3, okay? This is 2.60 PU. So upon that, we have to convert yung generation din natin per unit value. So this is only for formality para sa other problems, if we are going to encounter may value yung ating generation, is that at least alam natin on how to convert it, okay? So, MW natin is 0, di ba? Para silang 0 divide by 100, so 0 PU siya. Then, as for the next step is that we have to compute for the net injected power at bus 1 and bus 2. So, how are we going to get that? We have this formula, PG2 minus PL2. So, basically lang, yung kaninang kinompute natin for our load and generation, itong data na to, is that we are just going to subtract them. So, our PG2, lahat ng generation natin is 0. As you can see here, lahat sila is 0, automatic. PL2, 3.90. QL2 is 3.10. PL3 is 2.90. And our QL3 is 2.60. So, we are going to arrive with an answer na negative lahat sila. Negative 3.9, negative 3.10, negative 2.9, and negative 2.6, which is all in per unit. Okay, next is the formation ng Y-bus natin, the Y-bus system, or the Y-bus matrix rather. So, of course, kung maalala natin sa Y-bus matrix natin is that we are going to solve for our admittance. But, sadly or unfortunately, hindi siya given dun sa ating table kanina, pero meron tayong given impedance. And we all know that to get the admittance, we are just going to reciprocate the values of our impedance. Therefore, yan, may mga formula tayo na 1 over Z12 kasi nakita natin dun sa table natin kanina, meron siyang impedance for line 1, 2, 1, 3, and of course, 2 and 3 or 3, 2. So as you can see here, alam naman natin na ang Y12 is equals to Y21. So reciprocate natin yung ating value ng impedance ng line 1, 2. So that's basically 1 over 0 plus J0.030, and it will be equivalent to negative J33.3333 Siemens. Okay, so you can get your calculators. Pwede kayo sumabay sa akin. You can just pause this video and we can move on to computing. So you can also check kung tama ba yung pagka-compute ko because maybe I have typed written wrong, but our final answer will be derived or will arrive to similar if compare natin ang GS at NR. So I assure you that. Then now, yung Y13 and minus Y3 is equal to our Y31. So basically, ang reciprocal ng ating 1 over impedance ng line 13 is 1 over j 0.0125. So that's going to be equivalent to negative j80. Then y23 natin, or admittance ng line 23 and admittance ng 32 would be the reciprocal of our impedance ng line 32. So that's 1 over j 0.05. And it will be equivalent to negative j20. Then now, we have to get the values of our y11 and y22 and y33. And as you can remember sa y-bus admittance matrix natin, we had discussed na sa off-diagonal, it must be multiplied by negative. Then meron tayong diagonal values na y11, y22, and y33. So yun yung isa-solve natin ngayon. And solving for y11, we all know that all the admittances that is associated to our bus 1, that will be the value of our y11. So as you can see here, y12 plus y13 and y10. But since due to neglected charging admittance, it was stated in our problem, ang y10 natin is equivalent to 0. Okay, as for substitution ng values, so ang ating y12, as you can remember here, ang y12 natin is negative j3, 33.3. I'm sorry kung pabalik-balik tayo just to confirm. And yung ating y13 is negative 80, okay? Then ang atin naman na y10 is 0. So basically, if you're going to compute for that, we will arrive to an answer of negative j negative j 113.33333. So now, same goes din sa ating y22 and y33. All of the admittances that is connected to our bus 2, i-sum up natin yon, and that will be the value of our y22. And as for y33, all of the admittances connected to our bus 3, that would be all the and the sum of that would be the value of our y33. So y21 natin negative j 33.333 plus yung y23 natin, just to confirm, that would be negative j20. And if you are going to sum up those, we are going to get an answer of negative j 53.3333. So I made sure na 4 decimal tayo dito so that we can be close to the most accurate answer. Then y33, y13 natin is negative j80. Then our y23 or 32 is going to be negative j20. So that would be equivalent to negative j100. So with that, we have to change this values into polar form. So that's shift 2, 3 sa calculators natin if you're going to be in the mode 2 or complex form. So ang value na ating y11, y22, and y33 respectively is 113.3333 at an angle of negative 90. And 53.3333 at an angle of negative 90 as well. And our y33 is 100 at an angle of negative 90. So next up, alam naman natin that we had solved already for y12, y13, and y23 and yung kabaliktaran nila. Wherein hindi natin siya na-multiply sa negative. And usapan natin if y ba siya and off diagonal, it always have to be multiplied with negative 1. So yung values natin kanina, which is negative j 0.33, dun sa ating y12 is that we just have to multiply with negative and of course magiging positive 33.3333 at an angle of positive 90 if it would be changed to our polar form. Same goes sa y13, multiply natin siya. So that's negative j80 times negative 1, that would be positive j80. And in polar form, that would be 80 at an angle of positive 90. y23, 20 at an angle of positive 90. Same process lang siya. So if we are to form our y-bus matrix now, so that you can see 3 by 3 matrix ang meron tayo because we have a 3-bus power system. Okay? Sabi natin, the number of our bus is that would be the n by n number of our matrix. So basically, we have to put yung values natin, yung na-flash muna dito. So 33.333 at an angle of 90, it will be placed to y12 and of course to y21. So as for 18 at an angle of 90 is y13, y13, and y31. So as for y23, ang y23 natin is 20 at an angle of 90, 20 at an angle of 90. And of course, yung y11 natin, y22, and y13 as flash kanina yung values natin. After getting our y-bus admittance matrix is that we are going to solve for the iterative computation. This starts our first iteration. So this is going to be our formula. So medyo complicated siya. But what we did is that we have to designate the slack bus voltage and our starting voltage. Kanina sabi natin our V1, V2, and V3. This is actually V3, okay? V3 yan. So V2, V1, V2, and V3, same lahat sila ng voltage, which is 1 plus J 0 volts. So the first thing we have to do is solve for our P2 minus JQ squared, JQ2 rather, over Y22. So that's basically ito. So ito yung part na yon. So yung P2 natin minus JQ2 is all over Y22. So yung P2 natin value kanina is negative 3.90. You can go back and look at it kasi hindi ko na siya na-flash sa screen dito. Pero for the sake lang, balikan natin. So negative JQ2 natin is J 3.10. Negative J 3.10. So, kaya siya naging plus. So, ang Y22 natin is 53.333 at an angle of negative 90. This is just basically the substitution of values na nakuha natin kanina. So, by means of dividing the two of this, we will arrive to an answer of 0.0934 at an angle of negative 128.4802. So now we have to get the value of y sub 21 or admittance of y sub 21 divided to y sub 22. So as you can see is that lagi natin siya dinidivide sa y sub 22 because of this formula. So lahat ng nandito is that dinidivide siya sa y sub 22 for the sake of complying with our formula in the first iteration. Okay, so now ang value ng y sub 21 natin is 33.3333 at an angle of negative 90. Ang y22 natin, as I've said, is 53.333 at an angle of negative 90. So by means of dividing both of them, we will arrive to an answer of 0.6250 at an angle of 180. Actually, pwedeng hindi nyo na siya is-solve one by one. Pwede mo siyang i-insert na lang dun sa mismong formula natin if you want it na direct. And you can get it more accurate by means of that. Pero hindi naman masyadong kalayuan yung discrepancy if you are going to do this. Para lang, for the sake na meron kayong data na babalikan na. Okay, hindi kayo malilito. So you can do that as well. But for me, my preference is that I want to dissect all the data that I need to input in my formula. Now, as for our y sub 23 divided by y sub 22, so ang value natin is 20 at an angle of 90 divided by 53.333 at an angle of negative 90, and we will arrive at an answer of 0.3750 at an angle of 180. So I am not going to calculate it one by one because it will take us more than an hour or 2 more hours just to get our final answer. So, as nilagay ko na dito yung formula because yun yung ifa-follow natin, yun lang din naka-flash kanina. So, as for our equation 1, substitution lang. So, as sabi natin kanina, kaya nawala na dito yung 1 over y sub 22 because dinivide na natin all by y sub 22. So, now we are just going to input our values. So, lahat na nakuha natin is that ito yung sa una, ito yung sa pangalawa, at ito yung sa pangatlo. So, ito yung value natin for P2 minus JQ2 all over Y22. Ito naman yung dinivide din natin ng Y21 all over Y sub 22. Tapos dito yung dinivide natin yung Y sub 23 all over yung Y sub 22. Huwag kayong malilito because dinivide ko lang siya. Ito, dinivide ko dito. Ito, dinivide ko dito. Ito, dinivide ko dito. And that will also be our formula for our third voltage. Now, as you can see is, hindi ko pa sinubstitute ito, at ito, because basically, they are all just 1 plus J 0. Okay. So later, we are going to answer that, yung final answer nito, by means of pagsabay doon sa V3 natin. So now we are to solve for our V3 as you can see here. So kunin ulit natin yung data. So that's basically ulit yung P3 minus JQ. 3 natin is i-divide by Y sub 33. So our values for P sub 3 is negative 2.90. Then negative JQ3 natin is negative 2.60. So negative then negative is equals to positive. So basically, naging plus lang siya yung operation dito. Then over yung value ng y33 natin, which is 100 at an angle of negative 90. So by means of dividing these two values, we will arrive to an answer of 0.0389 at an angle of negative 131.8779 degrees. So next up is our y31. This y31 divided by y sub 33, or our admittance 33. So our value is that 80 at an angle of 90 divided by 100 at an angle of negative 90. So that will be equivalent to 0.80 at an angle of 180. As for our y23, actually, this is y sub 33. Y sub 33 to, hindi ko lang din napalitan. Pero we are solving now for this formula. So, our y sub 23 is 20 at an angle of 90 all over 100 at an angle of negative 90 ang value ng ating y33, right? So, solving for this, we are going to arrive at an answer of 0.20 at an angle of 180. Again, pwede kayong sumabay so that you can see on what is happening, na bakit yun ang naging answer, and we would have less doubts along the way para mas maka-catch up din kayo. Now, for our equation 2, it should be written, yung V3 natin, lahat na nakuha nating values here, it will be substituted. So, here yung first na value natin, ito yung second value natin, this our third value. Okay, so next up is that we are to solve for the first iteration ng Q equation 3 at equation 4 natin. So as you can see, sabi ko nga kanina, hindi natin muna siya kinuha yung value ng V1, V2, and V3 dun sa kanina. Bakit hindi siya diniretso? Because it would be easier for us to see if side by side yung V2 and V3 natin. Okay, so lahat ng walang value natin kanina is that we are just to input 1 plus J00 because the value of our slack bus and the value of our V2 and V3 initially is 1 plus J00, and it was mentioned or it was written in our table. Given na siya. Okay, dun lang kayo titingin lagi pag first iteration. So you're just going to solve for this equation. Kahit i-type nyo na siya diretso dun sa ating calculator, but you have to take note that we have this formula here na naka-conjugate. So meaning, if you transform this into polar form, kung lumabas dyan is negative 90, for example, at an angle of negative 90, the conjugate of that would be positive 90. So the thing that you have to enter, the value you have to enter in a calculator is positive. Okay? Pero either way, negative or positive dyan sa part na yan is that we will end up with the same answer because that's just 1, value ng 1. Okay? Wala tayong reactive value dyan. So if we are to calculate for that, we are going to have an answer of 0.9447 at an angle of negative 4.4388 degrees voltage. As for V3, substitute ulit yung lahat ng values natin for V1, V2, and V3. So that's going to be 0.9634 at an angle of negative 2.5931 degrees voltage. Okay, from that, we have to solve for our second iteration. So we have to take note na sa first iteration natin is that our second voltage is this one, and our third voltage would be this one. And now, we are going to use these values na nakuha natin and associate it with the second iteration. So as of now, we are to solve for the second iteration, di ba? So ang formula na gagamitin lang din natin is yung ginamit natin sa first iteration. So go back lang tayo, papakita ko sa inyo. Ito, this is the formula still na gagamitin natin through getting the values of V2 and V3 in the second iteration. So mapapansin ninyo that this V2, V1, and V3, and this V3, V1, and V2. So, practically, technically, is that nagpalit lang sila, nag-switch sila. So, ang values ng V2 natin here would not be the initial value of our V2. Ang gagamitin na natin is yung V2 na nakuha natin in the first iteration. And as for V3, same goes din, yung nakuha natin dun sa ating first iteration. So, as you can see here, V2 to, right? So, yung V2 natin na nakuha dito sa first iteration, imbis na 1 plus J00, like here in the first, is that ito na yung ating gagamitin. And we have to take note the conjugate. So, instead of inputting sa calculator na negative 4.4388, is that we have to put positive. Okay? So, since V1, itong katabi ng ating second term is that same pa rin na 1 plus J00 since slack ba siya and it's constant along the way. Next is that ito ay V3. So, our V3 na sa first iteration natin is yun ang isa-substitute natin yung values. So, wag kayong malilito na bakit dun sa una is 1 lahat ginamit because that's our initial value. In the second iteration, paulit-ulit ko kahit sa previous nating videos, I have said na kung ano yung makuha mong value sa first iteration, yun ang i-associate mong value na kailangan sa second iteration and so on and so forth. So, it is important to be correct instantly sa first iteration before moving forward sa ating second iteration because it will all be a mistake if mali. Okay? Then we have to solve for V2, V sub 2 for our second iteration. So that will be equivalent to 0.9229 at an angle of negative 5.5184 degrees voltage. As for our V3, same process. So nauna lang yung denominator niya is V3 or our V sub 3. So use our V sub 3 value dito sa ating first iteration. Substitute over here sa denominator. V1, same as it is a slack bus, 1 plus J00. Then our V2 this is the value of our V2. Okay, solving for that, we will arrive to an answer of 0.9566 minus 2.7901 degrees voltage. So, here is the data summary just to para lang makita ninyo kung ano yung nakuha natin sa first and second iteration and later we will have a comparison in the very end. Pero ito yung values na nakuha natin for V2. This is the first iteration and this is our second iteration. For V3, is this the first iteration and this is our second iteration. Kung makikita ninyo, hindi sila masyadong nagkakalayo sa isa't isa upon iterating from one to the second iteration. Okay, now moving forward sa Newton-Raphson method natin. So as you can see, mahaba yung process natin for GS, pero I guarantee you na mas mahaba yung Newton-Raphson method natin because as per discussed sa previous videos, I have gave you a warning. Na sa Newton-Raphson method, it converges to a more accurate value up to 2 to 3 iterations pa lang, but it is a complicated process to undergo as maggagamit pa tayo ng Jacobian matrix instead ng paggamit lang ng Y-bus admittance matrix. But let's move forward and solve using the Newton-Raphson up to 2 iterations. So we are going to still use the same data sa first so that we could have a comparison sa nakuha nating value sa Gauss-Seidel. So this is going to be our primary formula at first. So yung data natin, ipakita ulit natin dito sa screen. So ang nakuha natin sa Y2 to Y3, nandyan lahat yon, sinulat ko lang so that hindi tayo malito or mawala. Okay? Ito lang lahat. Lahat ng sinolve natin sa Gauss-Seidel, ito lang din yun. Okay? Ito lang din. So, medyo napabilis siya ng konti because we had primarily undergone the data of solving for our initial computation values or our initial values rather. Okay. So, now, ito din yung other formula na kailangan natin i-undergo because we are going to differentiate this first formula. So basically, differentiate lang natin siya. So I think, if I'm not mistaken, yun yung ilalagay natin sa matrix natin. Yeah, that will be all the values that will be that we will solve or that we will get in this following numerous formulas is that yun yung ilalagay natin sa matrix natin. Okay? Okay, now. So as you can see, for the sake na hindi tayo mawala, is nilagay ko dito sa gilid yung ating data and yung ating mga formula. So mukha lang siyang complicated because iba yung formula or iba yung initial value na kailangan nating hanapin. But if you will look at it, ito lang naman lahat ng data na nakabigay na dito is that substitute mo lang siya dito. So that's the main purpose and why we had presented it to be that way. Like here, yung nakalagay dito is yung V2 daw natin. So asan yung V2 natin dito? So that's 1. So i-substitute lang natin dito, so which is 1. Ano yung value ng V1 natin? Here, it is 1. So, makikita natin this one as well. Yung ating y21, where is y21 over here? It's 33.333. And sinubstitute lang siya over here. So, that's basically it. Isa-substitute mo lang yung values na kinompile mo doon sa ating formula. So, from that, so, dedire-diretso ka na. You can check it on your own. Nakabigay naman na yung data. You just have to substitute it. Okay. So, our differentiation of P2 all over delta 2. So that's 1 times 1, 3.33 sine 90 minus 0 plus 0 plus 1 times 20 sine 90 equals 53.333. As for our second is that negative 1 times 1 times 20 sine 90 is equals to negative 20. Then as for our third one is negative 1 times 1 times 20 sine 90, it's also as well negative 20. 1 times 1 times 80 sine 90 minus 0 plus 0 plus 1 times 20 sine 90 is equivalent to 100. As for this one is negative 1 times 33.333 sine 90 plus 2 times 1 times 53.333 sine negative 90 minus 1 times 20 sine 90 is equals to 53.3333. Then negative 1 times 20 sine 90 is equal to negative 20. Same goes for this, negative 20. Same lang naman kasi sila. Then negative 1 times 80 sine 90 plus 1 times 20 sine 90 minus 2 times 1 times 100 sine negative 90 equals to 100. Then after getting all of those values is that we have to fit it in our Jacobian matrix. So as you can see, yung ating values dito is just all the same. Okay? All the same lang I mean, not all the same totally. Pero kung mapapansin niyo, hatiin niyo itong dalawa because dalawa yung Jacobian matrix na gagawin natin, which is yung first 4 and yung last so consecutive 4. So this is 53, negative 20, negative 20, 100. 53, negative 20, negative 20, 100. So meaning our J1 and our J4 will be equivalent sa isa't isa. Basically is that yung 53 natin, that's our J1. This is our J11, J12, J21, and J22. And ganun din yung sa ating second matrix. So as you can see here, finorm lang siya into a Jacobian matrix. Then after that, for this problem, J1 and J4 is as computed above, we have to assume constant siya all throughout our iterative process. Either first iteration, second, and so on, is that constant natin gagamitin itong matrix nito. Okay? So now, we have to compute for our P sub 2 calculated and P sub 2 specific or they have the other term in this book Pero in other books and in other references, they have P calculated, Q calculated, then P specific, then Q specific, okay? So our formula for that, for the sake of formality, ang mangyayari dito. Kasi lahat naman ng nasa calculated is equivalent to 0. So same goes, lahat naman ng data is na-present na natin kanina. So you can just go back, okay? Then substitution of values na lang ulit. So 1 times 33.333 because y21 is this one. Yung ating delta 21 is 90, y22 is 53, delta negative 90, 23, 20, then cos delta 23 or our angle which is 90 degrees. So we can just basically have a copy, lahat ng copy natin na na-solve natin para dire-diretso lang ng pag-substitute, okay? Then you can follow this process. So by means of computing for that, it will be equivalent to 0 watts, and our P3 is equivalent as well as 0 watts. Then we have to solve for our Q2 and Q3. And as I've said, just for the sake of formality, kaya pinakita yung formula na yan, but it is equivalent to 0 watts as well. Doon sa previous natin, noon sa Newton-Raphson, di ba, ang nakuha din natin for all the calculated values would be 0. So I just think na there will be cases na hindi siya 0, but here we had solved everything with 0. Now we have to solve for our SCH yung nakalagay dito. I don't know if it's schedule. if I'm right na schedule yun. But in the book, they call it that way. Pero sa nakikita ko, it's specific or specified yung nakalagay dun sa baba. So, basically, yung value natin here na nakuha lahat, which is all zero, ima-minus natin dun sa values na nasa load natin. Di ba? We have 390, 290, 310, and 260. Yung nasa table natin, dun sa part ng load. So, familiar naman na tayo dun. And we are just going to arrive with all the negative values of the load values. So that's negative 3.90, negative 2.90, negative 3.10, and negative 2.6 respectively. Okay, so now I had flashed here in the screen yung ating pagkuha ng value ng delta P2, delta P3, delta Q2, and delta Q3. So the general formula would be our P2 as SCH minus P2 calculated. So lahat ng calculated naman natin is 0. And yung na-solve natin lahat dito is negative lang lahat ng load values natin. So that's just equivalent to kung ano yung value na SCH natin, yun na din yung value ng ating delta P2, P3, Q2, and Q3. Now, we have to form the matrix. Now, we are dwelling na sa first iteration natin. Na from this part, yun na lang din yung isa-solve natin from dun sa second iteration. So we have to form the matrix and you have to inverse the matrix. So kanina, nakuha na natin yung Jacobian matrix. Actually, if we are to go back sa ating Newton-Raphson discussion, I have presented to you na yung ating matrix na formation is like this one, wherein ito yung Jacobian matrix natin, and this is our piece, and this is our delta. Wherein here, we are going to substitute this value since nakuha naman na natin siya dito and yung Jacobian natin is nakuha na rin natin. So we are to solve for our delta 2 and our delta 3. Okay, so now is that the twist in this process is that we have to get the inverse of the matrix of our Jacobian. So itong Jacobian matrix na ito is we have to inverse it and get its value. So hindi na natin siya kukunin manually. We can push it in our calculators. You can go to mode sa matrix. Then upon going to the mode of the matrix, you have to put or input our values here in our Jacobian. Then after that, you have to press AC. Upon pressing AC, you will, if I'm not mistaken, you have to press shift, then shift 4, 5, I think. Then after shift 4, 5 is you have to pick matrix A. Kasi yung na-store mo na matrix is matrix A. Then yung matrix A na yon is lalagyan mo siya nung raise negative 1, which is nakikita mo naman dun sa ating calculator. May negative 1 dun, di ba? So yun lang, you have to inverse that, then equals, then we will get an answer of 0.0203, 4.05 for 1 times 10 raised to negative 3, 4.05 for 1 times 10 raised to negative 3, then 0.0108. So we can also get this through the process of yung manual calculation siya. But it will just be mas matagal because we just, may mga process pa yun na we have to exchange this one and this one, then put negative sign on it, or yung denominator na kunin natin is yung yung product nito, then product nito, that's going to be our denominator for this type, ganon. So it's a long process. You can always search it online, but for me, it's way easier and more accurate to use the calculator since we are privileged to. So now, we are to solve for the value of our delta 2 and delta 3. So this is going to be our angle for voltage 2 and voltage 3 for our first iteration. Okay, so the thing is, nakapagsagot na rin naman tayo last discussion. So basically, to get that, we have to multiply this J11 doon sa ating value ng P2, then our J12 sa ating value ng ating P3. So that's multiply, then yung products nun, i-add natin to one another, which is equivalent to negative 0.0909. But this is in rad or radian. But kailangan natin is in degrees. So to be able to change radian value to a degree is that we have to multiply it by 180 all over the pi. which is 3.14, 16, and so on. So from that, multiplying the two, we are going to have an answer of negative 5.20, 82 degrees. Okay? So next stop is that to solve for S3. Same process, but yung kukunin naman natin is from this one, then multiply it by 0.0108, I mean negative 3.90. So, same process lang, but the thing is, instead na dito sa J11 is sa J22 na. Yung J22 natin, multiply by P2, and our J23, 22, oh wait, I'm sorry, I'm wrong. So basically, it's just the same process. Ang pinagkaiba lang is that yung J12 natin, multiply natin sa P2, and our J22 multiply sa P3. So upon that, multiplying that, then adding the two values, we will come up with negative 0.0471 multiplied with 180 all over our pi. And we will get an answer of negative 2.6986 degrees. Now, may delta na tayo, we have to get the magnitude value of our voltage. So technically, is that to get that, yung ating formation. So this is going to be the formation of our matrix. Hindi na siya P, but we are going to use the reactive power. And all over here, we are going to solve for the value, magnitude value of our V2 and V3 for our first iteration. Since yung, pwede ito may iba actually. Kasi ang nakuha natin, di ba, sa ating Jacobian 1 matrix and Jacobian 4 matrix, is that parehas yung values nila and also yung formation sa matrix. But there will be instances na pwede silang magkaiba. And you have to take note na yung Jacobian matrix natin, to get the magnitude V1 and V2, ang gagamitin natin doon is yung Jacobian 4 or yung second na matrix. Okay? So after that, we have to just reform our matrix, and basically to solve for V2 and V3 is that the same lang. Same lang yung gagawin natin like delta. Okay? So this is multiplied with this one, then add it with the product of this one to this one, and we will come up with an answer of negative 0.0735. As for V2, multiply this one to negative 3.10, and this one to negative 2.60, and the sum of both of them will be equivalent to negative 0.0406 degrees. Then, you're asking, bakit sobrang liit naman po ng voltage niyan? Because we're not yet finished yet. That is not the final magnitude for V2 and V3 rather. So, the thing that you have to do is that, kung ano yung value mo for our V2 kanina here, yung initial voltage mo, i-add mo siya dun sa nakuha mong change in V2. So, ano yung initial voltage natin ng V2 and V3? That's basically 1. So, ang mangyayari, 1 plus yung value natin here ng V2, which is negative 0.0735. And as for our V3, ang value natin is 1 plus negative 0.0406. So, we are going to come up with an answer of 0.9265 for our V2, and for V3 is 0.9594. And therefore, the values sa ating first iteration, V2 natin is 0.9265 at an angle of negative 5.2082 degrees voltage, and for V3 is 0.9594 at an angle of negative 2.6986 degrees voltage. Okay, now, we are to solve for our second iteration. For the second iteration, sabi ko nga, is that we are just going to undergo the same process. So, hindi ko na siya ipapakita ng di ba? I-substitute lang natin ulit. Kung ano yung ginawa natin sa una, yun din ang gagawin natin sa second part. The only thing is, kapag may V2, V3, delta 2, and delta 3 na values na kailangan i-substitute, lahat ng gagamitin natin would be the value na nakuha natin sa first iteration. So, kunyari, meron tayong isa-substitute sa P-calculated na V2. So, ang value ng magnitude V2 natin is 0.0962. Then, kunyari, may delta 2. So, this is going to be yung value na gagamitin natin. Okay? So, same lang dun sa Gauss-Seidel. So, hindi ko na nilagay yung formula. We just have to substitute it. So, as you can see here, ito yung value ng ating V2, di ba? Just to prove it. So, yan, yung V2 natin. So, kasi ang nasa formula ng P-calculated natin, right, is nauna yung V2. So, upon substituting all the values, is that we will arrive to an answer of negative 3.5819. As you can see, yung P calculated natin dito, hindi na siya lahat zero. May values na siya because we had substituted the value from nakuha natin sa V2 and V3 doon sa first iteration. Sa second, P3 calculated natin is negative 2.8352 by means of substituting the values and solving for the answer. As for our reactive powers naman sa calculated, for Q2, that's negative 2.7350. And for our Q3 calculated is negative 2.3827. Okay, from that, same process, ang gagawin natin is we have to solve for our delta P2, P3, Q2, and Q3. So, kailangan lang natin i-minus yung ating P2SCH doon sa ating nakuhang P2 calculated. So, as you can see here is finlash ko na din yung sa first iteration to give a comparison. Diba sabi natin ang SCH values natin is ito. So, substitute lang din natin siya sa second iteration. Then, lahat na nakuha natin kaninang calculated, ito yon. So, bakit po naka-plus na? Kasi lahat ng nakuha natin kanina is all in negative. And yung operation natin is negative. So, basically, it will just change to a plus sign or magiging addition lang siya. So, from that, calculating the answers, we have negative 0.3181, negative 0.0648, negative 0.365, and negative 0.2173 respectively for the change in P2, change in P3, change in Q2, and change in Q3. So after that, kung natatandaan ninyo, is we had formed na yung ating matrix. So, dating gawi, yung ating P2 and P3, na formation, then our Jacobian, then we will solve for our delta 2 and delta 3. Then we just have to reform the form of the matrix. So, kailangan natin i-inverse. So, nagawa na natin kanina. Then, just input the values of our, what do you call this? P2 and P3, which is yung new value na natin ang input dito. So, basically, we will arrive to a different answer for delta 2 and delta 3. So, from that, we have to multiply this to our negative 0.3181 and this to negative 0.0648. The sum of that will be negative 6.7201 times 10 raised to negative 3 multiplied by 180 all over pi because we have to get the degrees of it. So that's negative 0.3850 degrees. As for our S2, is that same goes. This is multiplied by negative 0.3181. This is multiplied by negative 0.0648. And this sum of both will be giving an answer of negative 1.9894 times 10 raised to negative 3, then multiplied by 180 all over pi, will give us an answer of negative 0.1140 degrees. And with that, we have to solve naman yung sa ating V2. So, hindi ko na siya uulitin. Same process lang siya. So, ang V2 natin will be negative 8.2905 times 10 raised to negative 3. And our V3 is negative 3.8266 times 10 raised to negative 3. Just the same process na ginawa natin kanina. Just have to follow that. Substitution natin. Huwag malilito pala. Guide ko lang kayo na ang value ng Q2 and Q3 natin is yung new value na sinolve natin kanina, which is this one. So, negative 0.365 and negative 0.2173. So, besides that, wala na namang ibang binago except, syempre, yung isosolve natin is V2 and V3. Okay? So, upon that, magtataka kayo bakit both of them, delta 2, delta 3, V2 and V3, bakit maliit yung values nila? Itong V2 and V3 naka-raise pa. So, the thing is, for the second iteration, unlike sa first iteration, both the delta and both the V values ay kailangan mag-undergo ng addition with our na-solve and with our S2 and S3 ng first iteration. Okay? So, lahat ng values ng V2 and V3, delta 2 and delta 3 ng first iteration natin, kailangan natin siyang i-add sa lahat ng V2, V3, S2, and S3, delta 2 and delta 3 na values natin. So basically, the thing is, kailangan lahat na nakuha natin sa first iteration is associated pa rin siya sa second iteration in the sense that yung final values na pwede nating makuha for delta 2, 3, V2, and 3 is that kailangan natin siyang i-add. So as you can see here, ito lahat yung values natin sa ating first iteration. So S ang ating delta 2 is negative 5.2082. Ito yung ating delta 3, ito yung ating V2, ito yung ating V3. Then, kailangan natin siyang i-add doon sa lahat na naunang nakuhang values natin dito sa second iteration. So, i-example na muna natin itong V2 at V3 since ito yung data na nakikita natin. So, as you can see, ang V2 natin is negative 8 point something. So, i-substitute lang siya dito. Naging negative siya kasi kahit plus siya because negative yung nakuha nating value here. And as for the second one, yung V3 natin, same goes, sinubstitute lang siya dito. So, ganun din sa ating delta 2 and delta 3. So, negative sila pareho. So, that is the reason why minus siya ang operation niya right now. So, from that is upon doing the operation, is that yung delta 2 natin is negative 5.5932. Ang ating delta 3 is negative 2.8126 degrees. Then our voltage for V2 is that 0.9182 and 0.9556. So our data summary for our first and second iteration by means of using the Newton-Raphson method is that our V2 is 0.9265 at an angle of negative 5.2082 degrees voltage, and our second iteration is 0.9182 at an angle of negative 5.5932 degrees voltage, and our V3 is 0.9594 at an angle of negative 2.6986 degrees voltage, and our second iteration is 0.9556 at an angle of negative 2.8126 degrees voltage. So, para nilagay natin siya sa table so that you can compare yung first and second iteration, and later we can compare this table to the table dun sa ating Gauss-Seidel method. And now, our letter C and D problem. C and D problem, pagsasamahin ko na sila ng process. Kasi magkasunod lang naman yun. So, they are just interrelated to one another. We are to solve now for the line flows and the line losses. Okay? So the first thing is that we have to compute for the slack bus power after the second iterations, and the slack bus power is then computed. So the thing that we have to do now, and ano din pala, disclaimer, since yung ating Gauss-Seidel and Newton-Raphson, may discrepancy sila, di ba? They have to be similar in the values. But disclaimer, the thing is that kailangan nating mamili kung alin do sa dalawa ang kailangan nating isolve for line flows and line losses. Kasi it would just, kahit isolve natin both, is almost similar din naman yung magiging answer. So we just pick the Gauss-Seidel na values for V2, V3, delta 2, and delta 3 so that maging ano lang tayo, na isang way or method yung pinagkuhanan natin ng values. Pero technically, they're just the same, okay? So, upon that, we have to list our data again so that hindi tayo mawala sa process. V1 natin, 1, then angle of 0. V2 natin for Gauss-Seidel. Yung second iteration ito yung second iteration value ng V2, which is 0.9229 at an angle of negative 5.5184. V3 is 0.9462. Ang ating delta 3 is negative 2.7935. Then values ng Y11, Y12, Y13. Let's just input that there. Then after that, you can see flashing the screen is the formula that the first formula that we will use, okay? So, substitution lang din. Since nakita nyo naman kanina lahat ng data natin, so we just have to substitute it with this one. So, yung V1 daw natin, E square. So, that's 1 squared. Y11, 113.333. So, cos, ganyan. So, we just have to substitute. And upon substituting all the values na nakita nating data kanina, is we will arrive to an answer of 6.6835 PU. So if we are to transfer it in megawatts, that's going to be multiplied by 100. So that's an answer 668.35 megawatts. Then, same process sa ating Q. We just have to follow the formula, substitute our values, and we will arrive to an answer of 6.2753 per unit. And if we just want to get the value in megavar, is that would be 627.53 var, because we had just simply multiplied it by 100. So the next step is that we have to calculate for the line flows and line losses. Okay, so this in comparison dun sa dalawang method na ginawa natin, which is this is totally different kasi associated siya in either of the methods. So, I just wanted to conclude na mas maiksi yung process na ito in comparison na sa dalawa. Pero yun. So, the thing that we have to do is follow this formula here. So, this P12. So, same goes pa rin. Nothing new. We have to substitute the values. Then, upon substituting, we have to calculate it. So, upon pressing your calculators, we will arrive with the value of P12, which is 2.9584. PUMW for P13 is 3.6892. PUMW. P23 is negative 0.8303 PUMW. So, moving forward sa other values ng ating power, real power, P21 is negative 2.9584 PUMW. For P31 is negative 3.6892 PUMW. For our P23 is 0.830 PUMW. So, as you can see is that they somehow differ in terms of the sign. So, may kita ninyo dito lahat ng 213123 is, di ba ano lang sila, sabi natin is yung y, like y23 is equivalent to y32. So, here, it is different to, they are different from one another in sign lang. Okay? So, may kita ninyo na kung positive yung isa, kunyari, itong P21 is negative. Ang P12 natin is positive, as you can see over here. Okay? Yun lang. Then, after that is we have to calculate for the P-loss. So, basically, makuha natin yung value ng P-loss sa line 12, line 13, and line 23 by means of adding the values or the real power in line 1, 2, and the line power in the real power in line 2, 1. So, ang value na natin for P-loss 1, 2 is 0 PUMW. There are no losses, so that's ideal. Wala tayong losses, so 0 PUMW. And same goes sa ating power loss dun sa ating 1, 3, line 1, 3, and line 2, 3. So this is under sa real power natin. We don't have any losses. Pero if I'm not mistaken, sa reactive power natin is meron. So now, computing for the reactive line flows. Yung reactive line flows natin, I just want to clarify na meron tayong real power line flows. We have the reactive power line flows. And we also have the real real power losses, and we have the reactive power line losses. Okay? So, nadi-divide siya into reactive and real. Okay? So, now, may given ulit tayong formula. Since given ang data yung kanina, wala naman tayong like katulad dun sa pag-iterate natin na may mag-change ng value here. Kung ano yung value na present natin kanina, that's going to be the constant value all throughout in solving for the line flows and for the line losses. So basically, our Q12, so mag-move na ako sa pag-present ng answers, okay? So because this is just given naman na yung formula, we just have to substitute it, then compute for it. So upon pressing your calculators, our Q12 will be equivalent to 2.7126 PUM var. Since reactive power na to, then our Q13 is 3.5627 Q. This is 23 negative 0.6020 PU. Our Q2, this is 21, right? 2.2293 PUM var. As for our Q31, this is negative 2306 PU, and our Q32 is 0.6648 PUM var. So upon that, we are going to solve for our losses. So for our line 1, 2, that's 48.33 MVAR. Okay, so our line 1, 3 is 29.21 MVAR. For our loss in 2, 3 is 6.28 MVAR. So unlike dun sa ating what do you call this, real power loss in line 1, 2, 1, 3, and 2, 3 is that wala, that's very ideal for real power. So sa reactive power natin, meron tayong na-achieve na losses which is consecutively 48.33, 29.21, and 6.28 in megavar. Okay? So now, we are going to present the data summary ng lahat ng final answers natin na nakuha from our Gauss-Seidel, then Newton-Raphson, then our line flows and line losses. So here, may kita natin yung comparison ng values ng ating Gauss-Seidel and Newton-Raphson. So may I present it to you? So data summary ng V2 and V3 natin, this is all the values that we got for Gauss-Seidel and this is all the values that we got in Newton-Raphson. So, sa first iteration natin, ito yon, yung first two boxes. Sa first two boxes, may kita natin na ang value sa Gauss-Seidel ng V2 natin is 0.9447 and as for Newton-Raphson is 0.9265. So, it's pretty close. And for the delta 2 is negative 4.4388. As for this one is negative 5.2082. So they're pretty much close. So I think is that nagkaroon lang sila ng distinction because we had, hindi tayo nag-store ng values sa calculator. We are dissecting it into 4 and we are rounding it up to 4 decimal numbers. So, ayun, maybe doon nagkatalo and mas mahaba yung process sa Newton-Raphson natin. So, maybe that's the case on why hindi sila tugmang-tugma. Pero maybe if we had used, let's say, in Excel, di ba pwede natin to gawin sa Excel? We just have to drag the cells down to get the answers in different iterations. So maybe from that, it's pretty much close kasi sa Excel natin is that they're storing the formula, they're storing the values, yung mismong yung mismong value ng numbers na yun. Like if it's 16 decimal places, yun yung ini-store niya. But tayo, just sa sake ng pagpapakita on how the process occurs, is that we are rounding it up to 4 decimal numbers. Okay? So as for our Gauss-Seidel method in our V3, sa first iteration pa rin ito, is that nakuha natin 0.9634 and negative 2.5931 degrees. So sa Newton-Raphson natin is 9594 and negative 2.6986. So it's pretty much close once again. So I cannot conclude na may mali tayong nagawa or anything because we had double-checked everything. And sobrang close or napakaliit ng discrepancy na nakuha natin sa isa't isa. Okay? So as for the second iteration, ang V2 natin is 0.229 and negative 5.5184. And same goes dito, 0.9182, negative 5.5932. So as for our V3, 0.9566. Ito yung pinaka-close na nakuha natin, 0.9556. And also, negative 2.7901 and negative 28126 degrees. So if we are to analyze this, is that we can conclude that if we are to manually process or solve for our Gauss-Seidel and Newton-Raphson with the similar given values or table of values, is that we are to arrive with a discrepancy from each other because we have different processes to undertake, but still, ang nangyayari is we are rounding it up to kahit parehas sila na 4 decimal numbers, we are still to arrive to different answers because yung process nga na kunwari meron na dinediretso na in comparison sa Newton-Raphson na baka doon is dinadissect pa. So, or may process siyang step-by-step talaga, which is a whole or general step na for the Gauss-Seidel, something like that. So, normal naman. Kaya nga, may distinction tayo between Gauss-Seidel and Newton-Raphson na more accurate daw ang Newton-Raphson because it is a more complex process to undergo and we have to get the Jacobian matrix pa and so on and so forth. Yan. So this is our answer in A and B question na solve for the Gauss-Seidel and Newton-Raphson for up to 2 iterations. So that's it. So as for the slack bus, sinama lang natin yung slack bus power. So kasi ginamit natin siya sa pagkuha ng values ng line losses and line flows sa real and reactive. So ang per unit natin is 6.6835 PU and for our reactive that's 6.2753 PU. So just to change it into MVAR or MW multiplied by 100. So for our real power, that's 668.35 MW. For our reactive power, that's 627.53 MVAR. Okay, so last one is the data summary for the line flows and the data summary for our line losses. So basically, sabi ko nga, nadi-divide sila sa dalawa. So we have the real power and the reactive power. For our line flows, ang ating P12 is 2.9584 PUMW. So our reactive naman is 2.7126 PU. Now for our P13 and Q13 is 3.6 892 PUMW and 3.5627 respectively. And P23 negative 0.8303 and negative 0.66020 for Q23. P21 is negative 2.9584. Q21 is negative 2.2293 PU. P31 is negative 3.6892 PU. MW, Q31 is negative 3.2306 PU MVAR, and our P23 is 0.8303 PU MW, and Q32 is 0.6648 PU MVAR. And as for the data summary for our line losses, ang real power natin is all zero, and for our reactive power, sabi natin for Q loss in line 1, 2, that would be 48.33 MVAR. And our Q loss for line 1, 3, that's 29.21 MVAR. And for our Q loss in 2, 3 is equivalent to 6.28 MVAR. So basically, our conclusion here is that dependent sila sa isa't isa because hindi natin makukuha yung line losses if we didn't get our line flow. So like for example, ang value ng P12 natin, kailangan natin i-add sa value ng ating P21. So same lahat, yun lang. Yung baliktaran lang ng values natin in real power in in reactive power. We just have to add it up so that we could occur to or have a result of the line losses. Okay? So our real power losses and reactive power losses is dependent on the values of our line flow. So therefore, we have to have a correct answer or accurate answers in the line flows pa lang so that we would arrive to an accurate answer as well in the line losses. And that will be the end of our journey in today's topic, which is the load flow analysis, wherein we basically just answered a certain question na hindi siya madali. That's very lengthy, so complicated. It almost took me 2 days to come up with the analysis of this. Actually, hindi naman 2 days. Parang I just gave myself 2 days to answer it because of course we have different requirements as well. Pero in one sitting, you can answer that. Right, kaya mo siyang sagutan in just one sitting, guided na given na ito. So you can just follow it. The process is so easy, but it's lengthy. Nakabigay na lahat ng formulas. You just have to undergo it and remember na ang iteration 2 natin is associated with your first iteration and you're good to go. Okay, so we have to remember na our load flow analysis is composed of our Gauss-Seidel and our Newton-Raphson, wherein in either methods, kung gagamitin mo siya with the same given values to be solved, is that we are to arrive to different answers, but only with a small discrepancy. And that is all for today, guys. Thank you so much for listening. So if you have any questions, again, you can find me at Katrina and Mendoza at slsc.edu.ph. Again, this is your reporter for today, and I hope you enjoyed it a lot. This is Katrina Mendoza, and always remember to stay positive and always look at the bright side. Again, see you in our finals episode. It's not a final episode, but yung pang finals natin na compilation episode. So bye, guys. Thank you so much, and God bless you. See you in the next episode.